بسم الله الرحمن الرحيم.
Assalamu alaikum and good morning students of class 9. How are you all? And I hope you all will be fine. And now here is the class of physics. It's the third virtual class of physics. Previously in second class we started discussing the chapter number 2, measurement. We discussed few fundamental definition from this chapter. Now we have the enhanced topic from those topics. Let me give you the review from the topics which I have taught you in previous class. We discussed about the physical quantities, then we have the fundamental quantities, then we have the derived quantities and their units. After that, we had the systems of unit. We discussed three systems of units, that was System International, CGS system and British Engineering system. Now we have three usually used measurement. We have to discuss that how much quantities are present in that measurement. The new topic and which we have, that is standard of length, means the measurement which we use in our daily life, that is usually the length, mass and time. We will discuss here the standard of length, standard of mass and standard of time. Our topic of today is the standard of length, and standard of length is the unit of the length is meter. Means meter is the unit which is used internationally for the length. Now the question should rise in your mind that how much length or how much quantity of the distance is present in one length, 1 meter, sorry. So that quantity of 1 meter is basically, we can define it as, the meter is the length of path traveled by light in vacuum during time interval of 29,97,92,458 fraction of 1 second. Let me explore this definition now. What this definition is telling you means, we have to define according to this definition that how much length is present in 1 meter. How it was assigned or how it's standardized that how much length is present in 1 meter. It was standardized as that when a light travels with the speed of 3 exponent 8 meter per second. It's the speed of light, means it can cover the distance of 3 exponent 8 meter in 1 second. So when the light is traveling the distance, in how much time it is traveling or it is covering the distance in the fraction of 1 second, and the fraction of 1 second is basically 29,97,92,458, means as much as fraction if we will make of 1 second, in that fraction duration of 1 second, how much the light travel, how much distance the light will be travel, it was considered as the 1 meter. It is bit difficult to understand that how much it will be covered the distance, because we have the measurement of 1 meter, we have the scale of 1 meter, but how much length is present in 1 meter, how it was assigned? It was assigned by the speed of light in vacuum. Vacuum means is a place where no gas is present. In vacuum, how much the light traveling or the covering the distance in that one fraction of a second, it is known as the 1 meter. Now we have the multiples and submultiples of meter. Multiples and submultiples of meter means that how much we have 1 kilometer, it's the larger unit of length than meter. Standard is the meter, but larger than the meter we have the 1 kilometer. In 1 kilometer we have 1000 meter, or we can write down that this 1000 we can write down 10 exponent 3 meter. We can write it in this way as well. Later we have the another one, like we have in 1 meter, how many centimeters are present? In 1 meter we have 100 centimeter. Means 100 centimeter will combine, then it will make the 1 meter. All this 100 centimeter we can write as 10 exponent 2 centimeter. Exponent value is easier to write down, and we avoid the errors in calculation when we are writing the values in exponent. We can write in this one as well, but exponent value is the convenient. Similarly, in 1 meter, how many millimeters are present? 1000 millimeters are present in 1 meter. This 1000 we can write as 10 exponent 3 millimeter. Similarly, we have in 1 meter, how many micrograms are present? Micrograms are 1,000, then 000 as micrograms are present in 1 meter. It's the symbol of micro. If I will write it down in the full form, that is microgram. It's equals to 10, we can write it as 10 exponent 6 microgram. It's a symbol of micro. Similarly, the last one we have, which is used in our whole syllabus for conversion, that is 1 meter having 10 1 meter having 100,000,000,000 nanogram, which we can write as 10 exponent 9 nanogram. Nano will be symbolized as small, and these are the some multiples and sub-multiples of meter. Means you can see in these all conversion, I have just standardized the meter. Every unit is equals how many quantities or how many other subunits are present into the meter. I have written related to the meter. 1 kilometer is equals to 1000 meter. 1 meter is equals to 10 exponent 2 centimeter. 1 meter is equals to 10 exponent 3 millimeter. 1 meter is equals to 10 exponent 6 micrometer. Sorry, it's meter, not gram. We are studying here length. 1 meter is equals to 10 exponent 9 nanometer. Now we have a numerical related to this topic, that is numerical number 2.3, in which we will more explain that how we can convert the meter into kilometer or meter into centimeter or millimeter onwards. The numerical is 2.3. We have 2.2, but the 2.3 relate to this topic. That's why I am just explaining you first 2.3 here. The question is the radius of hydrogen atom is 0.53 exponent minus 10 meter. The given value is 0.53 minus 10 meter. Convert it in gram, convert it in centimeter, millimeter and nanometer. Now what will be our data now? Kindly beta, when you're taking the physics class, I told you have your books and your lecture copy in front of you, and this question you have to solve in your fair copy as well. Now in the given, what is here, that is radius of hydrogen atom. Radius of hydrogen atom is 0.53 exponent minus 10 meter. In which values we have to convert? We have to convert in centimeter, nanometer, centimeter, millimeter, and then nanometer. We have to convert this meter into subunits now. Yes, in solution, what we will do, first of all, keep these conversion, these multiples and submultiples in front of you so that you can solve this numerical, otherwise it will be difficult to solve. Now we have, first one is, I am not removing this, just I have to link this topic with this numerical. Now in this solution, what you will do, from meter we have to convert into the centimeter, so you will directly look the relation between the meter and centimeter. Now we know that 1 meter is equals to 10 exponent to centimeter. It's the standard conversion of meter into the centimeter. What you will do, first of all, you should know that whether centimeter is higher unit or the meter is higher unit or the larger unit. Meter is the larger unit while centimeter is the smaller unit. When we have to convert the higher unit to the smaller unit, like meter we have to convert into the centimeter, it should be clear that which unit is higher and which unit is smaller. Centimeter is smaller and meter is higher. When we have to convert the larger unit into the smaller unit, what we will do, we will multiply the given value with the standard one value. Standard one means that how many centimeters are present into the meter? 100 centimeters are present into the meter. So we will multiply the given value with the 100. I am repeating that when we have to convert the larger unit into a smaller unit, we will multiply the given value with the standard one in which we have to convert. For that purpose, you should know that how many centimeter equals to the 1 meter. It's representing you. We have to multiply right now because we have to convert meter into centimeter. The given quantity we have, that is 0.53 exponent minus 10 meter. It's the given one. We have to convert into the centimeter. So what we will do, how much centimeter equals to into the meter, we will multiply that value with the given value. That is 0.53 exponent minus 10 multiply exponent 2, which is here, which is also equals to the 100. It will be rougher for your convenience. You can do it with the pencil. Now 0.53 exponent minus 10 meter, it will be equals to, if we will see that exponent minus 10 and exponent 2, they both having the same power. So they both have the same base and different power. When the bases are same, the power will be summed together. The base is, that is 0.53 will remain the same. We will write down 10 once time, then the power will be summed together, that is minus 10 plus 2. When we will solve this, it will be 0.53 exponent minus plus minus means 10 minus 2 will be 8. The sign with the 8 will be negative because we know the higher number having the higher power having the negative charge. So 0.53 exponent minus 10 meter are equal to the 0.53 exponent minus 8 centimeter. It is your first conversion. Now we have the next one conversion is, we have to convert the meter into the millimeter. Now millimeter is also the smaller unit than the meter. What we will do now here, we have to convert from meter to millimeter. For that purpose, what you will do, you will first write down the standard That is 1 meter is equals to 10 exponent 3 millimeter. The given value which we have to convert, that is 0.53 exponent minus 10 is meter equals to, because meter is the larger value and millimeter is the smaller value, so the given value which we have to convert, it will be multiplied with the standard one conversion. Means how much the millimeter are present in 1 meter, we will multiply that with the given value, that is 0.53 exponent minus 10 multiply exponent 3. This exponent 3 is basically the how many millimeters are present in 1 meter. Now your answer will be 0.53 exponent minus 10. These both bases are same, 10 and 10 are same bases, so their power will be summed together. Minus 10 plus 3. Your answer will be 0.53 exponent plus minus minus means 10 minus 3 will be 7, and with the 7 the sign will be negative because higher powered value having the negative sign. You will do this in the next step, but I have solved this here. Now the meter given quantity has been converted into the millimeter. Now the next one we have the nanometer. Whenever you are solving whenever you are doing the conversion, must remember the multiples and submultiples. Fine. Now our next conversion is the third part of this question is we have to convert the given value into the nanometer. For converting into the nanometer, just have a look on the standard value that how much nanometer are present into the meter. 1 meter is equals to 10 exponent 9 nanometer. Given one is 0.53 exponent minus 3 meter equals to 0.53. It's the given one. Exponent minus 3. Sorry, it's exponent minus 10. Minus 10 multiply exponent 9. Now bases are same, their power will be summed together. 0.53 exponent minus 10 plus 9, it will be equals to 0.53 exponent minus 1 nanometer. Now we have converted the meter into the centimeter, meter and then the millimeter. What was our topic? The first topic of today was the standard of length. Standard of length basically is the meter. How much length is present into 1 meter? We define that first. That how much centimeter are there? How much distance is present there? Now then we have the multiples and submultiples of meter. Our next topic is the standard of mass. Standard of mass means what's the unit used internationally for measuring the mass, that is kilogram. The question should rise in your mind that how much matter or how much quantity of a substance is present in 1 kilogram. Whatever we are purchasing, like we are purchasing sugar, flour, etc., we are purchasing it into the kilogram, 2 kilogram, 3 kilogram. First of all, the question should rise in your mind how much matter of how much quantity of that matter is present in 1 kilogram standard. Now first we will define the standard of mass. Standard of mass, it is means the international unit of standard of mass is kilogram. That is mass of platinum iridium alloy kept at International Bureau of Weight and Measures. Now what this definition is telling you, our topic is that how much quantity of material is present in 1 kilogram. It is standard. Now in 1 kilogram there is here is an alloy, that is platinum iridium alloy. What is platinum iridium alloy? Alloy is basically, first of all, the mixture of two metals. When we are mixing two metals, they will make a new substance which will be known as the alloy. Here is a place which is in Paris, that is International Bureau of Weight and Measure. In that one place, the international measurement like length, time and mass quantities are present there. Now in that one place, here is an alloy of platinum iridium. What is the weight of that alloy is there in that one place, that is International Bureau of Weight. What is the weight of this alloy? It will be called as the standard of 1 kilogram. How much will be the weight of that alloy? It will be is equals to the 1 kilogram of all the substances. We know 1 kilogram, but how much quantity is present in 1 kilogram? That quantity is internationally assigned by the weight of the alloy which is kept in the International Bureau of Weight. Now here are multiples and submultiples of kilogram. It is same as the meter, which we have discussed in the last topic, that is multiples and submultiples of multiples and submultiples of gram here now. Now 1 kilogram is equals to 1000 gram. Next we will see that in 1 gram how many milligram micrograms are present. Now such as now we have, that is 1 gram is equals to 1000 milligram, means in 1 gram how many milligrams are present? There are 1000 milligram. We can write this 1000 milligram as exponent 3 milligram. Similarly 1 gram is equals to 1,000,000 microgram. We can write it as exponent 6 microgram. These are the three multiples and submultiples which we use in the whole syllabus. That's why I am just introducing you only this three conversion here. Now we have the numerical related to the conversion of mass, that is numerical number 2.2. The numerical 2.2 is, I am just directly making data here. You can copy or see the numerical from your book. Here is 2.2. The mass of an electron is 9.11 exponent minus 31. The data is, or the given is, mass of an electron it is equals to 9.11 exponent minus 31 kilogram. What they are asking, they are saying to convert it into the gram, milligram and microgram. So we have to convert in gram, milligram microgram. We have to convert this. Here are the three conversion which is relating with this numerical number 2.2. It's numerical number 2.2. In the solution, what we will do, here is we have to convert into the, first we will convert into the gram. What we will do here, we will write down the standard one conversion, that is 1 kilogram is equals to the 1000 gram. What is our given value? Our given value is 9.11 exponent minus 31. We have to convert it into the gram. When we have to convert the kilogram into the gram, for that purpose you should know which is the higher value. Kilogram is the higher value while gram is the smaller value. So as I have told you in the previous numerical, when we have to convert the higher value into the smaller value, we will just multiply the given value with the standard one equals. Standard one equals means how much gram are present into the kilogram. There are 1000 gram are present into 1 kilogram. The given value is into the kilogram, that is 9.11 exponent minus 31. You will multiply this 9.11 exponent minus 31 with exponent 3. Exponent 3 is basically the 1000, representing you the 1000, because we are converting the higher value into the smaller value. Remember, when we are converting higher to smaller, we will multiply. There will be another case when we will convert the smaller to higher. At that time, we will divide. Right now, we are moving from higher to smaller value. You have to learn this. Now, what will be happen? That's 9.11. Same thing will be happen here. Bases are same. That is 10, and here is base is the 10. You will write on the 10 once time. Then minus 31. Their power will be summed together. Minus 31 plus 3. Answer will be 9.11 exponent minus plus minus 31 minus 3, it will be is equals to minus 28. And now this 9.11 exponent minus 31 kilogram is equals to 9.11 exponent minus 28 gram. Now in the multiples and submultiples, I told you the first one 1 kilogram is equals to the 1000 gram. Then I told you the next one 1 gram is equals to 1000 milligram, and 1 gram is equals to exponent 6 microgram. I did not tell you the direct conversion from kilogram to milligram and microgram. Here I am writing again, that is 1 kilogram is equals to 1000 gram. 1 gram is equals to exponent 3 milligram, and last one was 1 gram is equals to exponent 6 microgram. I did not tell you the conversion directly from kilogram to milligram, kilogram to microgram. In our question, we have to convert the kilogram into the milligram and microgram as well, but I did not tell you that one conversion. What will you do? You will just directly follow the gram into the milligram and then the microgram, because we have converted the kilogram into the gram. We can do directly, but there can be the chances of error. So whenever you have to jump from kilogram into the milligram and microgram, what you will do? You will first convert into the gram to avoid the errors. What you will do now? We will go through the gram now, as in the for the next one. That is, next point is we have to convert it into the gram we have done. Now we have to move to the milligram. For next one part, that is conversion from kilogram to milligram. What you will do? You will first write down as, means as we know 9.11 exponent minus 31 kilogram is equals to 9.11 exponent minus 28 gram. What we will do now, we will just take this one value. We will now convert gram into the milligram, then gram into the microgram according to are multiples and sub-multiples. I am not directly converting the kilogram into the milligram and kilogram into the microgram. What you will do now, there is a as we know that 9.11 exponent minus 31 equals to 9.11 exponent minus 28. So we know that 1 gram is equals to exponent 3 milligram. What you will write down here, instead of 1 gram, you will write down the calculated value which we have done previously. That is 9.11 exponent minus 28 is equals to 9.11 exponent minus 28 multiply exponent minus 3, which will be equals to, if we will solve that, it will be equals to 9.11 exponent minus 28 plus 3. Sorry, it's 3 only. 3. It will be equals to 9.11 exponent plus minus 28 minus 3 will be minus 25. Now we have converted into the milligram. So you will write down here with the answer milligram. It will be your answer. Means 9 point exponent minus 31 kilogram is equals to the 9 point exponent minus 25. I am repeating, I did not directly convert kilogram into the milligram. First we converted into the gram. Then this gram value is converting into the milligram according to our given multiples and submultiples. After that, the last one is the conversion of kilogram into the milligram. Kilogram into milligram. I am removing this one. Now the last one is conversion of kilogram into microgram. Same you will do that, as we know that 9.11 exponent minus 31 kilogram is equals to 9.11 exponent minus 28 gram. Now we will convert this gram into the microgram, because we studied the multiples of gram into the milligram and as well as the microgram. So 1 gram is equals to exponent 6 microgram according to our multiples and submultiple. Instead of this 1 gram, we will write down the given 1 gram, that is 9.11 exponent minus 28 equals to, you will multiply with this exponent 6 because gram is the larger and microgram is the smaller value. That is 9.11 exponent minus 28 multiply exponent 6. Your answer will be Your answer will be 9.11 exponent minus 28 plus 6. It will be equals to exponent minus plus minus 28 minus 6. It will be equals to minus 22 microgram. Here is the numerical number 2.2. It is bit different from the first one which we have done 2.3, just because we did not directly convert the given value. First we convert the kilogram into the gram, then we convert the gram into the milligram, then we convert the gram into the microgram. If you have any confusion, you can see the video again and again, because it's not compulsory that you will understand it once time. It's the conversion, it takes time to understand. With this topic, I am stopping my lecture here. Our last topic for the standard is lab, that is standard of time, which is second. We will discuss the definition of second and the conversion of second in our next class. And numerical number 2.4 is basically related to the standard of time. Now hope you have understood today's topics, which was the standard of length and standard of time. Come towards the homework. The homework is to memorize the chapter number 2. In chapter number 2, what the topic we have learned from the in first lecture and in second lecture. All the topics you will learn here are basically the definition in this chapter. Today's definitions are standard of length and standard of mass. So you can learn those definitions from your book, page number 14 and 15. Both the definitions are there, and you will solve these two numericals in your copy. Leave 2.4 until we will learn the conversion of time. With this, I'm closing my class. Hope you will do your homework and you will learn the topics which I have given you. Thank you so very much.